Hey guys, in this lesson we will talk about characteristics of different functions. The functions that we are going to deal with are, first is fx equal to x, that is a linear function, fx equal to x square quadratic function, fx equal to x absolute function, fx equal to square root x function, 2 to the power x, that is exponential function, reciprocal function, and sinusoidal function that could be either sin x or cos x. These functions can be categorized based on 6 characteristics. Therefore, the characteristics that we would consider is, the first one is domain and range for each of these functions. Second is x and y intercepts. Next characteristic is continuity and discontinuity. Next is symmetry. Symmetry could be 2 types. One is even, one is odd. Next is end behavior. And last one is intervals of increase and decrease. We can also consider another characteristic here, that is positive and negative intervals. Now, all of these characteristics can be determined using the graphs of these functions or using the equations. If we are given the graphs, then we directly write down the characteristics from the graph. However, if we are given equations, then we change the equations to graphs and then write down these characteristics. That's why these characteristics are also called graphical characteristics. Let's consider the first function, that is fx equal to x to the power 1. That is a linear function. We know graph of a linear function would look like this. It's just like a straight line. Now, looking at the graph, domain of this function, because it's a linear function, there is no limit or no restriction on domain and range. So domain is XER, range is YER. That's the first characteristic done. Second characteristic is x and y intercepts. We notice here that the graph crosses through x and y axes at this point. This is where the graph crosses the y axis, and this is where the graph crosses the x axis. Let's say this point is negative 0.5 and this point is positive 0.5. So we can write down the x-intercept as 0.5 and y-intercept as 0.5. However, if we make an exact graph of fx equal to x to the power 1, that's supposed to pass through 0 point. In that case, the line would look like this. And if this is the line, then the x and the y-intercept will be both 0. You will not always be given parent function. You can be given any function. For example, if you're given fx is equal to x minus 1, then in that case, this is the y-intercept. We'll be making the line from minus 1. Slope is 1 over 1, so it's rise 1, run 1, and this is how the line is going to look like. In that case, your y-intercept would be negative 1 and x-intercept would be positive 1. So it depends upon the equation that gives you a graph, and from the graph, we write down the characteristics. Because we are doing parent function example, so we'll be taking up characteristics of the parent functions. Next characteristic that we have to write down is continuity and discontinuity. That means, do you see a break in the graph? So this is my graph line. Do I see any break? Is it breaking? Breaking means, do I see any asymptote? So there is no discontinuity. If there is no discontinuity, this graph is a continuous graph. Next characteristic that we have to write down is symmetry. Now, what is meant by symmetry? A graph can be symmetrical about x-axis as well as it can be symmetrical about y-axis. How do we decide symmetry about each axis? Let's say we consider this graph. We see the left side of the graph, that is this side, and the right side of the graph is exactly same. So it has symmetry about y-axis. So left of the y-axis and right of the y-axis looks exactly same. So this graph has symmetry about y-axis. If the graph has symmetry about y-axis, then that type of symmetry is called even symmetry. However, when we look at this graph on the left side of y-axis is below x-axis, so it's in this section, and right side it's in this section. So this is not a symmetry about y-axis. This type of symmetry is called symmetry about origin. If a graph has symmetry about origin, you would always see a diagonal type of symmetry. Means the top left and the bottom right, or the top right and the bottom left is where you would see same sides of the graph. Then it is called odd symmetry. Therefore, in this particular example, we see odd symmetry. And we notice this type of symmetry only in parent function. If we look at this equation, this is also a linear equation, whereas this graph is not symmetrical about origin. So we would call this graph to have no symmetry. Next characteristic we have is the end behavior. Now to find out end behavior, these last three characteristics are very, very important. To find out end behavior, or to find out positive negative interval, or to find out increasing decreasing interval, we have to walk on the x-axis. When we are looking for end behavior, we start from origin and we move towards the two ends. So we start from the middle, that's the origin, and we move towards the two ends. First, we move towards the left end. That means we are approaching x in the negative direction. So we are approaching end of x. That's why we call it x approaches negative infinity. And how do we write that down? If x approaches negative infinity, so my x is approaching negative infinity, this is my graph endpoint. So my graph is going to continue like this. If x is going to approach infinity, my y will also approach negative infinity because my graph is going down. Y approaches negative infinity. This is how we write down end behavior for the left end. To write down end behavior for the right end is when x approaches positive infinity. And we check here the right end of the graph. So this graph is going like this. X is approaching positive infinity, so as y. That is also approaching positive infinity. Therefore, we would write down if x approaches positive infinity, y approaches positive infinity as well. Next characteristic is interval of increase or decrease. Interval of increase or decrease also we would have to walk on the x-axis. Let's make the graph again. Now when we are writing interval of increase or decrease, we have to start walking from left to right on x-axis. And this case is always true. No matter what type of graph we are asked to write down interval of increase or decrease. So we have to start walking and we have to move in this direction. When we move in this direction, we notice how the graph is going because this is our line graph. From left, so this is the left side of the graph, this is the right side of the graph. And we notice here that from left to right, the graph is going up always. Therefore, this graph is always increasing. So how do we write down interval of increase? Interval means we only have to mention the x values. So my graph is increasing from left to right. Therefore, I would say my graph is increasing from negative infinity to positive infinity. And how do I write down the answer? I write down interval of increase. We put interval in these brackets from negative infinity to positive infinity. And this is the only way that you have to write it down. For interval of decrease in this particular graph, we do not see any. Therefore, we would write down none. Next characteristic is positive or negative interval. Because it's again interval, that means we have to look for x values. And here also we have to walk from left to right. Now, positive interval means the part of graph that lies above x-axis. And negative means the part that lies below x-axis. We notice that in this graph, this part lies below x-axis because this is our x-axis, and this part lies above x-axis. So this part is negative part of the graph and this part is positive part of the graph. But how do we write on the answer? Answer is always written when we are walking from left to right. So we would notice, and because this is interval, we have to only mention the x values from negative infinity when we are walking on the x-axis and we reach 0, we notice that the graph is always under x-axis. Therefore, we have a negative interval on this graph from negative infinity to 0. And from 0 to positive infinity, this graph is always positive. So we write on positive interval is from 0 to positive infinity. This is how we write on the characteristics when we are given the graphs or we are given parent functions. We just have to turn the parent function into the graph and then write on all these characteristics. Now you're expected to know the graphs of these parent functions from the previous grade. In case you need more clarification or you do not remember your parent function graphing, then I would recommend you to watch Introduction to Functions playlist in the YouTube channel that would give you an idea of how to make the graphs, and that would refresh your memory. Let's quickly take one more example. Now we are dealing with a quadratic function, fx is equal to x squared. First characteristic is domain and range. We know domain is xer because there is no limits on domain, and range is yer. There is a limit on range, so we would put y is greater than or equal to 0. You're expected to know domain and range from the previous grade as well. If you do not remember domain and range, again you would have to watch it in the playlist Introduction to Functions that has a video lesson for domain and range. Second is we have to write on x and y intercept, and we notice here also the graph crosses through x and y intercept at 0 or at origin, so it's 0. Third is we have to write on the symmetry. We know the symmetry is about y-axis, so it has even symmetry. Next characteristic is this graph a continuous graph or discontinuous graph? This graph is seen to have no break in the graph, no asymptote, no holes, nothing. So this is a continuous graph. Next we have is intervals of increase and decrease. For interval of increase and decrease, we always write from left to right. So when we go from negative infinity on the x-axis to 0, we notice that this graph is starting on top and going down. We are never supposed to check from middle to end for interval of increase and decrease. We're always going to check from left to right. So we check the left side and we check the right side, and we notice that this graph is going down. So there is an interval of decrease. We can write it down with this arrow kind of a thing, from negative infinity to 0. Then we have interval of increase, because from 0 to positive infinity, this graph does not stop here, it keeps on going up. That's why we say positive infinity. So from 0 to positive infinity, it shows us an interval of increase because the graph starts going up. Next characteristic that we have to write down is end behavior. For end behavior, we start walking from middle towards the two ends. So we always write on the answer this way. If x approaches negative infinity, what happens to the y? It is going up, up, up. So y approaches positive infinity. Similarly, if x approaches positive infinity, that is this way, y is still going up. So y approaches positive infinity again. Seventh characteristic is positive and negative intervals. For positive negative intervals, we start walking from left to write on the answer. However, we first notice where is the graph above x-axis and where is the graph below x-axis. Let's say we redraw the graph. Now this graph is always above x-axis. It's never going below x-axis. So there is no negative interval. So we can write down negative interval is not applicable, or there is no negative interval in this case. Whereas for positive interval, the graph is always positive. Answer always is written from left to right. So from negative infinity to positive infinity, the graph is positive. And this is how we write on all the characteristics, no matter which type of graph is assigned.